And guys, this is exactly the device we want to talk about today. The world famous JK-BMS. And in today's video, actually in tonight's video, we want to have a look at the settings in the JK-BMS. And I'm trying to explain everything as good as I can so you understand what all the settings in this BMS are for, what are they doing, how to set this all up correctly. And as always, if I forget anything, please leave a comment under the video and help me out here. And as I said in my last video here in this series about my settings in all my devices, I think the BMS ties in with the solar charge controllers very much. And as I always say, the BMS is part of the battery. Battery and BMS is basically one unit. Okay, oh, this is the wrong app. This is the DALI app. There it is, the JK-BMS. And here's our battery number 2, which is the middle battery in our system. And I go a bit on the side here because people still want to see me. Apparently some people watch this show here they want to see me, they want to hear me talking. They don't give a crap about batteries and solar and all this kind of stuff. They are not interested in all this stuff. They're just here to hear my accent, apparently. I don't know, what accent? Okay, and here we are already in the status page on the dashboard of the JK-BMS. And before we get started, I want to show you something. When you click on these 3 lines here in the top left-hand corner, see the little pen symbol there? You can actually rename the BMS to whatever you want. So my one is the battery number 2. This is my second battery in the battery shelf. You can modify the name, and you can also modify the password to get into the app or to make changes to the app. I'll talk about this in a second. And on the other side of the screen, you've got these 3 dots. We have a quick look what's going on there. There's a system log where the BMS, where it basically logs all the faults, all the warnings, everything which happens in the BMS, which is not normal, I would say. And you've got these timestamps here, like in days, hours, minutes, and seconds. Probably if you are not at home and something happens, you can have a look later on in the log file here, and it gives you a rough idea what actually happened. Okay, history of version. I'm currently running the version 4.6.5. Not even sure if this is the actual version here because they're changing and the app doesn't update automatically. So you have to go to the website and look for a new version there. I link this website down under the video and also on my website in the BMS section, so you can always find it there. As you may remember, when we tested the 4S version of the JK-BMS, I was not able to connect because my app was not up to date. So always make sure if you get new hardware from JK to update the app as well. It doesn't do it automatically. Privacy and protocol is just the fine print. I don't know, never looked into this. Language settings, English, Chinese, and the about. Nobody clicks on the about, but here you should, because this gives you really good information here. For example, what type of BMS you actually have. This is the B2A24S20P. That means JK for the JK-BMS, obviously. B2A is the balance 2 amps, so it has a 2 amp balancer. The 24S is the maximum cell count the BMS can handle, and the 20P is the I think 20 stands for 200, so it's the 200 amp version. P is for, I don't know. Then we have the serial number, maybe not so interesting, but here now, the hardware version of your BMS. I think this is quite interesting because they've got so many different hardware versions now on the market. So if you have a problem or something and post your fault under one of my videos or in a forum or something, it is probably handy if you take a screenshot of this here and post the hardware version, also the software version, so people can actually compare what they have on their system to yours. And it's probably important that you are running the same hardware. Otherwise, settings or functions may be different. And it also gives you the software version. This is the software which runs on the BMS itself. So this is running on the processor here on the BMS directly. It's not the app software. The power on times, it's just a counter. 36 times apparently I've started this BMS. Well, we've done a lot of testing with this BMS right before it went into the battery shelf. And the total on time is 131 days, 20 hours, 45 minutes and 0 seconds. Date of manufacturing, quite interesting as well. And the version, Oh, I click. And the version 4.6.5, this is now the app version of your actual mobile app. So these are all the information you can get under these 3 dots in the top right hand corner. In the middle between these two, you can still see the power on time of the BMS. And when you turn it off, it still remembers this time, so it keeps adding onto it. So this is the lifetime. Yeah, this is the lifetime turn on time of the BMS. That's just what they present. I don't know. So here at the bottom, we have status, settings, and control. And you can just tap on them to go through this list, or you can swipe on the actual screen here to go left and right as well. So both methods are possible, click or swipe, whatever you prefer. Whenever you do this or you change any parameters in the BMS, you can always hear a beep from the BMS itself. I'll show you quickly. Probably can hear it now. Yeah, there's the BMS, and it beeps. It's just a confirmation beep, and I think it's okay. It's not super loud or something, you know, but it gives you an audible tone. It has received the command. So, okay, let's have a quick look here at the status page, at the dashboard, how I call it. So at the top here, we've got the voltage and the amps going in or out. So negative amps are the current is coming out of the battery into your load, and positive amps are we are charging the battery. Unlike the Heltec BMS, where it is the other way around, which always confuses me. And obviously the voltage is your overall pack voltage if you have 12 volt, 24, 36 or 48 volt. Battery power in watts. So we are currently delivering 11.6 watts or 23.3 depending where it just jumps. And the remaining battery capacity is 12% state of charge, it shows us. Which kind of is true, but let me tell you, I've got 3 different BMSs running here for quite a while now, and I've got the Victron Smart Shunt. So I've got 4 devices which are calculating or measuring the state of charge, and they are all different. They're all showing a different value. So I had to pick one, which actually is my point of truth, and I'm not looking at other devices anymore. And of course, this is the Victron Smart Shunt because I think it is the most precise device I have here to actually count state of charge or calculate state of charge. And it also reports all this information to the solar charge controllers, inverters, to the whole Victron system. So this is my point of truth, and these ones here in the BMSs are just what the BMSs do. The overall battery capacity is 280 ampere hours. This is something you need to set when you firstly program your BMS. The remaining capacity is 34.5 ampere hours in my case, which is exactly the 12%. So this is just a calculated value. And the overall cycle capacity the battery has done is 742.9 ampere hours. This calculates ampere hours in and ampere hours out of the battery and just presents this as a sum, as a number here. The cycle count is 2, so I have done 2 full cycles with this battery connected to this BMS. And because I'm just doing little micro cycles every day, so I'm going at the moment from like 10% to 14%, and then overnight it goes back to 12, and then the next day it goes to 16, and the next day it goes down to 9. So these are all very little micro cycles I'm doing, but the BMS is actually calculating them all up. All these little micro cycles added up now correspond to 1 full cycle, and then it displays them here in the dashboard. Next line is the average cell voltage of 3.219 volts. This is just across my 16 cells now, is an average. The deviation or the delta cell voltage, the difference between the highest cell in your pack and the lowest cell, is 3 millivolt at the moment. And you can see this down here. The red one, cell number 2, is the lowest, and the highest one is number 1, or just jumped, number 5, 3.22 volts. It constantly changes, especially under load. So yeah, these information are not really important until we fully charge the battery again, and then we will see the deviation when we go in the steeper area of the curve then. The balance current, of course, is at the moment 0 because we are not balancing at all. This is also happening at the higher state of charge when we are fully charging the battery. And then we've got 3 temperatures here. The Mosfet temperature inside the BMS, 16 degrees. Isn't that freezing cold? And I'm only on a 1-layer t-shirt. And then we've got two external battery sensors. Battery sensor T1 sticks inside the battery block, and the battery sensor T2 measures the temperature in the main circuit breaker of this battery bank. That's just where I put them. And then down here you can see all the cells from number 1 to number 24 if you have a 24S configuration. I have only 16 cells connected, and you can see all the single cell voltages. And underneath there is this cell wire resistance. So yeah, I'm not sure if this actually shows you the resistance of the balance lead for cell number 1. That's my understanding, right? So 149 milliohms. If this is true or not, I don't know. They all look very much the same. Number 9 is a bit higher. Number 8 is a bit higher. I don't know. Is it important at all? I don't know. I never looked at these numbers. Don't know what to do with them. So, oh yeah, here at the top, I've forgotten. There's actually a display line where it shows you your charge and discharge buttons and the balance function as well. Charge is on, discharge is on, and balance is on. So it is enabled, so to speak. So everything is turned on. This is the normal operation of the BMS now. And we probably go to the controls on the right-hand side here first, because this is where you can actually turn off your charge, your discharge, and your balance, and it will show this actually then on the front page as well. To change all these settings, because they are grayed out at the moment, you need to verify your password of the BMS, which is here 1, 2, 3, 4, 5, 6, and this is the password you can actually change at the beginning, where I showed you where to change the name of the BMS as well. We click on verify, and now everything is enabled here. And for example, if I turn off discharge and we go back into the dashboard, you can see at the top here, discharge is now turned off. There won't be any current going out of the BMS anymore. You can see it's 0.0 now. And if we go back and turn this back on here and go back, there will be probably a bit of current now going out. Now 0.5 amps. There's no load, only a little bit of light here. Standby of the inverter, that's it. And this is what you can do here, charge, discharge, and balance. You can enable or disable this function then, very straightforward. And also with the new version now we have an emergency button here. And this is a very interesting feature. I wasn't sure quite what that actually is, but this is actually overriding your security switches of the BMS. So if your BMS has turned off because the battery is fully depleted to protect your battery and has turned off your inverter, you can flick the emergency switch here and it actually turns the battery back on. So in an emergency situation, that's why it's called emergency probably, you can actually deeper discharge your battery if you still need the power, right? So if you are on a boat, for example, and you need still power for your light or for your radio or something in an emergency, you can deeper discharge the battery, potentially harm the battery, damage it a little bit, but you have still power on the boat. I think this switch totally makes sense, and you can turn this on and off to override the security of the BMS then. All right, let's have a quick look at the settings, because there's not too much to see actually here. Oh, we have to go all the way up. So at the top we can see 4 buttons: lithium iron, lithium iron phosphate, and LTO. This is what the JK-BMS can handle. And you press these buttons only once, please. Only once at the beginning when you set up your BMS for the very, very first time. Never ever afterwards, because it will override all your settings with the default settings for this profile. I've done this multiple times and I said, well, I'm sure I have changed these settings here. But yeah, in the meanwhile, I pressed on the lithium iron phosphate button again, because I thought, well, why not, you know? Tell the BMS what you have. And it overrode all my settings again, so I had to do everything again. Here you can also modify the password again, old password, new password, confirm password, very straightforward. If you want to go away from this 1, 2, 3, 4, 5, 6, and you probably should do this, because everyone with this app can just run around and scan for these BMSs, right? Especially in a caravan park or in a marina or something, you will have heaps of luck finding BMSs which actually respond to your application on your phone. You can find the DALI BMSs, the JK-BMS, the JBDs with the Xiaoxiang app. It scans for you and potentially there's a good chance that people have not changed the password and you just can get in. You can change parameters. You can, don't do it. Don't be nasty. Be a good person. Talk to this person and say, well, you should change your password because I've got access to your battery right now. And then we have two sections here. One is the basic settings and the other one is the advanced settings. So the basic settings are only 5 points. Cell count 16 in my case. It is a 16S battery, 48 volt system, 16 battery cells in series. So you have to tell the BMS what kind of battery you have. The battery capacity, if you have done your own capacity measurement and you have 285 ampere hours, then put 285 in there. I don't really care too much about this. This is just for the BMS to calculate the state of charge. You can see here at the top again in the dashboard. So put the damn capacity in to give the BMS a rough idea what you actually have. The balanced trigger voltage is a bit misleading text, I would say here. This is not the trigger voltage when the balancer turns on. This is only the trigger voltage difference. So in this case, I have put in 0.05 volts, which is 5 millivolt. So if all the 16 cells are within these 5 millivolts, the balancer will not start. Only if the spread is more than 5 millivolt or whatever you set in here in this setting, the balancer will actually start. And you need to be above the start voltage of the balancer, which we will see in a second here. And the next two steps are very helpful here, even they are not working correctly in the JK-BMS. But this is the calibration voltage. So you can use your calibrated voltmeter and measure your battery voltage and then put exactly this voltage into this field here and click OK to calibrate the BMS to what the actual voltage in your battery is. It's a calibration, right? And you can do the same with the current as well. What can I say? What I have found so far is the voltage is relatively okay because it doesn't change too much between, say, 50 volt and 53 volts, but the current is all over the place. So if you calibrate your BMS with a small current from 0 to 10 amps, it is fairly accurate then. But if you pull like 60, 70, 80, 100 amps or something from the BMS, it will differ from your actual ampere meter quite a lot. And you calibrate it again in the higher area of your usage pattern, like 80, 90, 100 amps. And then you will see it is very inaccurate with the lower currents again. So it is just another thing to calculate your ampere hours, what you have used and the state of charge. So if the amps are not accurate, it doesn't show the correct state of charge and remaining capacity ampere hours. Again, if you have more than one device in your system which calculates state of charge, pick one. Pick one and stick to it. And don't ever look to anything else. It just confuses you. Yeah, and these are the basic settings of the BMS. We now click on the advanced settings here. And we can see a bit more, but not too much. And they are fairly straightforward. So stick with me here for a moment. And I will scroll this up here. So these are all the advanced settings. So at the top we have the cell over voltage protection, the cell OVP, the OVP. And I always set this to 3.65 volts because this is the maximum voltage the cells can do as per the specifications of the manufacturer EVE. You can set this to 3.6 volts as well to give you a bit of headroom, but I usually leave this on 3.65 because this is the maximum the cells can do. If we hit this 3.65 volts, the BMS will shut off your whole battery. And this is why you should always have a BMS. If your solar charge controller charges only to 3.5 volts, for example, this is all fine. It will then stop charging your battery, right? But what if your solar charge controller is faulty? Yeah, you have a surge, you have a lightning strike or something, and your solar charge controller is faulty. The next morning the sun comes out and it pushes amps into your battery and overcharges your battery until they are so bloated you won't get them out of the shelf anymore. It looks like you have 16 small blue elephants in your shelf just because you don't have a BMS. And some people still think you don't need a BMS, a solar charge controller is totally fine. No, it's not fine. No. You always want the BMS. You always want the JK-BMS or any of the other BMSs, but I would recommend the JK-BMS. You always want the BMS for this purpose. This is a security, this is a safety function of the BMS. It turns off your whole battery if one of the cells, one of the 16 cells here, is over 3.65 volts. Because then something is not right and the battery shuts down. Yeah, it shuts down. Safety reason. BMS is a safety device. If this happens, then it waits for the cell over voltage protection recovery voltage. This is the OVPR. And I've set this one to 3.6 volt. It waits until all the cells are below 3.6 volts, and then it automatically turns on the battery bank again. And if your solar charge controller is still faulty, it will push energy into the battery until one of the cells gets to 3.65 again, and it turns it off again. If you are not at home, you don't know if your charge controller works correctly, right? Unless you monitor your battery 24/7, like I do with the Victron VRM. I always have this app running on my phone. I have to constantly recharge my phone because I look at this VRM all the time. I'm checking, I'm controlling, I'm a total freak, I'm a nerd. But usually you don't look at your battery all the time. You let the electronics control everything and the BMS will take care of that, right? So, and the next two lines, actually, they should be swapped. So line number 4 is the cell under voltage protection. This is the exact same, just on the other side of the curve. You know, if you discharge your battery very, very low. And again, here I have set 2.5 volts. This is the lowest voltage the cells can do as per the manufacturer's specification. I'm an extreme guy. As you may know, I do some testing here and there on the channel, and I like to fully charge the batteries to 3.65 and fully discharge to 2.5, just to measure something, to test something, to explore, and just to annoy other people because I'm going into the extreme. And here again, if we hit the 2.5 volts, the BMS will shut down your whole battery. Yeah, if you're not at home, and if your inverter or your load does not shut off automatically at a certain voltage, the BMS will watch this, and if one of the cells hits 2.5, says, no, there's something wrong, shut it down. And then it waits until the battery voltage slowly climbs to 2.7 volts, so all the cells need to be over 2.7. And then it turns on the battery bank again and allows the discharge of your battery again if there's still load available. So to trigger the security, one cell hitting the 3.65 maximum or the 2.5 is enough to actually disconnect your battery. But then to turn it on automatically, all battery cells, all of them need to be under 3.6 volts or above 2.7 volts again. One of your many batteries can trigger the safety, but all of the batteries need to be within the safe area to turn it back on. And we also have a power off voltage here. And this is a bit of a safety feature to actually, I don't know, this could be something for a cabin. You know, you've got a cabin far, far away from everything, got a solar panel there and a battery or something set up. And in wintertime, maybe the solar panel doesn't bring any power into the battery and the battery goes lower, lower, lower. The BMS will turn off your load at 2.5 volts, but then still the BMS pulls power from your battery. So this is basically the voltage when the BMS shuts itself down completely. So there's no load on the battery anymore. There's nothing, absolutely 0 amps, nothing anymore. And this really is to protect the battery from a deep discharge then if the BMS is the only load on your battery. But these BMSs, they pull only a few milliamps from the battery, but over time this can be enough to actually discharge your battery and then damage it or destroy it even then. So I don't use this function here because, as I said, I'm a control freak. I'm always monitoring my battery with a VRM anyway, so I know what the status of my battery is. And I have set this so low to 2.45 volts because if I do testing with the battery, sometimes cells go a little bit under 2.5 volts and I don't want the BMS to disconnect from the battery. So that's why I have set this a little bit lower here in my case. But this is a setting you need to figure out where to set this one to. If you want this function, then set it to a value where you want the BMS to shut down completely. If you don't use this feature at all, you can set it to 2 volts, for example, and it will never shut down the BMS itself then. And then finally, we come to the start balance voltage. This is one of the most discussed values here in the BMS, and I've set mine on to 3.45 volts. And you may remember this number from the other video, from many of my 380 videos I've done in the last 1.5 years here on the channel. 3.45 volts is my magic number because this is the maximum I charge my cells to. Yeah, you can see now at the top here, we've got this cell over voltage protection of 3.65. This is the maximum the manufacturer allows you to charge the battery, but I go far lower to 3.45 only, which still gives me 100% of the capacity, but it doesn't stress the battery because the voltage doesn't go too high. So my solar charge controllers charge to 3.45 volts if all the cells are in balance, right? So if you have a 12 volt battery, for example, this would be 13.8 volts. This is the maximum I've set my solar charge controllers to. I'm not going any higher. And this is also the exact voltage when the balancer kicks in here, because this is what I want to achieve, right? Charging to 13.8 volts would mean every of these 4 cells in my 12 volt pack would be on 3.45 volts, ideally. If you have now one cell a little bit higher, you want to chop off the head, right? You want to push this one down because it's too high. If it's at 3.46 volts, for example, it's just a tiny bit higher than all the other ones, and you want to push this down, you want to discharge the cells so the voltage goes down again. And this is exactly what the setting does here. It kicks in at the same time when I hit my maximum charge voltage in the solar charge controllers. So I'm not balancing before I hit this maximum voltage with my solar charge controllers. So my absorption voltage in the solar charge controller is also my balance start voltage, because only battery cells which are higher voltage at this point of time I want to discharge. Some people start balancing already at 3.35 volts or 3.4 volts. I think this is far too early because you cannot really tell if a cell is already high in voltage or not, because you're still in the flat area of the curve, of the charging curve. So there's no point to actually balance earlier than, say, 3.4 volts at the earliest. Even this I found a little bit too low. It doesn't give you really an indication which cell is high, which is low. And balancing while you are still charging, I'm not a big fan of that. And because we are keeping the battery at 3.45 volts with the solar charge controllers for 1 hour, that was in my last video up here or something. So I keep my battery cells at 3.45 volts for 1 hour and let them absorb. That means the current the batteries take will taper off, and the lower the current is, the better my balancing works. So ideally, at 3.45 volts and the battery is fully charged, there's no current going in and out of the battery anymore. And then the active balancer of the JK-BMS can actually balance the higher voltage cells and put this energy in the lower voltage cells and balance all these cells perfectly out. And this works quite nice with the JK-BMS and the 2 amp active balancer. And then of leaving the battery there for 1 hour, I go into float mode, which then reduces the voltage from 3.45 to 3.35 volts. And of course the balancing will stop then, right? So, and this is probably the main reason I give the battery about an hour of time, so the balancer has actually time to do its job and balance the batteries. The new battery bank connected to the JK-BMS and the balancer works just fine at 3.45 volt and has enough time then within this hour to balance my batteries perfectly. So this is the reason I'm starting balancing my batteries at the same time I'm hitting the absorption voltage. And then we have the maximum balance current, which is 2 amps for this BMS here. You can set this to a lower value as well here if you have smaller batteries, like the Palo cells we have tested here many times on the channel as well. They only have 5 ampere hours, and you don't want to balance them with 2 amps. So you probably want to reduce your balance current to 0.5 amp or something for these kind of cells. And that's why you can adjust the balance current here as well for smaller batteries. And then we have the maximum charge current, which I have set to 150 amps. This is a 200 amp BMS. 200 amps charging, 200 amps discharging is the maximum continuously. Yeah, I'm not expecting to charge my batteries ever with 150 amps here. That would be insane if we have 150 amps outside, right? So this is just a number. I think this was actually the default value in here, so I haven't changed it at all. And the next value is the charge over current protection delay. This is how long it allows to go over this 150 amps for. So it allows to charge the batteries with over 150 amps for a maximum of 30 seconds, and then it turns off. Again, I don't think I have changed these settings. They might be the standard default settings of the BMS. Well, I don't reach the 150 amps anyway, so I'm not seeing a great point in changing these parameters for my circumstances here. But for your application, it may make sense to change them. And then we've got the charge over current protection recovery time. So once the BMS goes over 150 amps of charging current, and it does this for over 30 seconds, it turns off the whole battery bank. And then it waits for 60 seconds until it turns the battery back on to your system. And if your current is still over 150 amps, it does the same again. So it protects your battery basically. And then we have the maximum discharge current in amps, which I have set to 120 amps. Each of my battery banks, I can show you. Each of my battery banks has a circuit breaker, a DC circuit breaker with 100 amps. So I can discharge each of my banks with maximum of 100 amps here. And because it's a circuit breaker and it has a certain trigger curve, you can actually push up to 200 amps, 250 amps through this circuit breaker, and it won't trigger, at least not for a while. But if you set an overcurrent protection value here in your BMS, the BMS will disconnect your battery anyway before the actual circuit breaker triggers. And this is probably what you want. You want the BMS turning off before the circuit breaker trips. And here again, you've got a discharge over current protection delay. So it will allow 120 amps plus for 2 seconds, and then it shuts down the battery bank. Because it assumes there's something wrong, we're pulling too much current, it turns off your battery bank. And then after 60 seconds, which is the discharge over current protection recovery time, 60 seconds here in this case, I think this is default as well. And then it tries again to reconnect your battery and sees if there are still a draw of more than 120 amps or not. And it triggers again, or it leaves the battery connected. And here we have a Scp delay, which is the short current protection. This is one of the very important numbers you need to set in your BMS. It is for a short. In this case of the JK-BMS, I'm not 100% sure how the BMS defines a short current. Because usually in other BMSs you can set a short current like 500 or 600 amps. And if you have a short, you will have these 500-600 amps very quickly. And the delay when the BMS turns off then will be only a couple of microseconds, because it needs to protect all your cabling, all your equipment afterwards. So the 1500 microseconds here, I'm not 100% sure what the actual trigger for a short current in the JK-BMS are. If anyone knows, please leave your comments down below as always. And also we have a short current protection recovery time. So after a short, it waits 60 seconds and then turns on the BMS again. And hopefully there's no short anymore. And here afterwards, we have a whole lot of temperatures we go quickly through. We've got the charge over temperature protection. I'm not reaching these 50 degrees here inside the garage, not even here in sunny hot Australia, not even in summertime. No way. The highest temperature I've ever seen in battery number 1 in the bathtub was like 38 degrees in summertime. This was during charging with a 4 kilowatt system. So 50 degrees is really an extreme temperature. And then here again, we've got an over temperature protection recovery temperature. of 45 degrees. So if it triggers at 50 degrees, it turns off your whole battery. Again, a safety feature. And then it waits until the battery cools down to 45 degrees and then reconnects the battery. And we've got the same for discharging. This was charging and discharging as well. If we pull energy from the battery, it can do this up to 70 degrees as per the specs of the cell. I'm not even sure. I'll put this here on the screen. I'm not even sure if this is true. I probably haven't changed these settings because I'm not reaching these temperatures. And we also have a discharge over temperature protection recovery temperature of 60 degrees. So at 70 degrees, it turns off the battery bank and waits until it cools down to 60 degrees and then turns back on the battery. I mean, 60 degrees is fairly hot, right? I would not be comfortable with discharging my battery and having 60 degrees in these cells. And here one of the more useful temperatures is the under temperature protection temperature, which I've set to 3 degrees. Well, we've got in the middle of winter now, and you've seen we've got like 15 degrees in the battery bank. So this is probably as low as it gets here in the battery in wintertime. In the garage here, it doesn't go any lower. It warms up a little bit, like 3, 4, 5 degrees during the day while we are charging, temperatures increasing, but then during the night, that's all you get here in sunny hot Australia. So what happens if we go below 3 degrees? Exactly, it will stop charging. We can still discharge the battery then, but we cannot charge the battery anymore because this will definitely damage your chemistry, your battery cells, if we charge under 0 degrees Celsius. So to protect it, I've set this to 3 degrees just to make sure. Now this is just for the video here. You know, I'm not using this function at all. And again, we have a charge under temperature protection recovery temperature of 10 degrees. So 3 degrees, it turns off. It waits until the battery warms up to 10 degrees and then reconnects your battery again. Most likely this is important if you have an unattended system in a cabin, on a boat, in an RV somewhere parked during winter time. It monitors the temperature of the battery and turns off charging and discharging accordingly, you know. And again, this is a safety feature of the BMS. That's why you should have a BMS, because your solar charge controller cannot do any of that. And then we have the Mosfet over temperature protection. So if the BMS gets really 90 degrees hot inside, you should get a pot of water. You should get a pot of water and boil some noodles then, right? This is what we do with 90 degrees hot BMSs. We are making spaghetti, right? So 90 degrees internal temperature in the BMS shuts off the battery, and then it cools down to 70 degrees, which is the over temperature protection recovery temperature, 70 degrees. And you can see there's no OK button, so you cannot actually change these two parameters here at all. So these are fixed parameters inside the software, not changeable. User private data, I have no idea. This is new in this version of the software here of the app. I don't know. If someone knows anything, please leave a comment down below. Don't know what that means. Yeah, and these are all the parameters you need to set in your battery. Most of them are already set. Then you can start your journey with your battery, solar charge controllers, and BMS. And this is basically everything you need to do for a healthy and happy battery life. Now, underneath this section here, there is more. There is a con-wire res settings. Con means connection wire resistance in milliohms. So you can actually measure your balance leads and put these parameters into here. I don't know. Is that how it works? Guys, I never paid attention to resistance in balance leads. Really not. Because it is not important. The BMS only measures the voltage of your battery cells with these cables. And if they are only 200 millimeters long or 2.5 meters long, it doesn't make a difference when you measure voltage because there's no current flowing. And if the BMS balances this one cell, it doesn't measure the voltage at the same time. None of the BMSs do. They are all that intelligent. because there will be a voltage drop on these tiny cables, especially here with the JK-BMS, and you're pulling 2 amps from the batteries. So I'm not sure if this is a useful function here to actually measure and calibrate your balance cables for some reason. There might be applications, setups, scenarios. Leave your comments down below if you use this function here for whatever. Share what you know. Let us all be part of your experience. Yeah, guys, and this is basically everything you need to know about the JK-BMS and all the settings. But at least you know. And as you have seen, some of the settings need to be set accordingly to the specifications of your battery cells. Give your battery setup a good test. Drive it to the extreme and see if the BMS actually turns off your batteries at 3.65 volts, at 2.5 volts. Do an over temperature test with a heat gun or something. Get an ice cold spat out of your fridge and dip the temperature sensor into this refreshment and see if you can still charge your batteries under 3 degrees. As soon as you set up a battery with a BMS, I would always recommend test the BMS, see if it actually works with the parameters you have set. You've seen this here on the channel many times because I'm testing this all the time. I'm really curious to see what happens if we go to the extreme with the batteries, with the BMSs, with the solar charge controller, with the inverters. I'm really trying to push into the extremes to see what is happening and if this is all safe. Okay guys, I think this is all we need to see here on the JK-BMS. We've done through all the settings of the JK-BMS now. I explained everything as good as I can. If you have any additional information, please leave them down under the video for everyone to see. Share your knowledge, and if you want, share your own settings and explain why you have different settings and how they make sense for your application, for your setup, for your circumstances then. As always, I will take screenshots of all the settings and put them on my website. The link is down below under the video as well. If you want to have a quick look, a quick sneak peek onto the settings again, you don't need to watch the whole video here again. You can just look on the website and I've got screenshots of the JK-BMS there. Okay guys, as always, thank you so much for watching. Thanks for all your support here on the channel, especially these wonderful, great, beautiful people who have given me free money so I can buy beer, which makes me more beautiful. Thank you so much for your financial support here as well. Thank you for everyone else who is leaving comments, like, share, subscribe. This is totally cheesy. Thank you, of course, for everyone else who is leaving comments under my videos, sharing your own stories, your own experience. I'm always keen to read what you are up to. So many good information here on the channel just from the viewers. Amazing. Thank you so much for that. And as always, guys, stay charged, stay safe with the BMS. And thank you again for watching. See you then. Bye-bye. I will probably have a beer now. Thanks again, guys.